Hi, I'm Jesse with Mastercam, and in this video I want to show you how to properly leverage and control high-speed modes on a toolpath by toolpath basis with your Haas CNC. Most programmers and operators are mainly familiar with high-speed machining functions like enabling and disabling the HSM option, and adjusting setting 191 between rough, medium, and fine. The issue with using this method is that settings are globally on or off for all operations in a given NC file. You can end up with settings that are either too accurate, which slow down your roughing operations, or too loose, which can affect precision for finishing operations. Ideally, we should be looking at different settings for different toolpath types and applications. There is also setting 85, which controls the max corner rounding, which aids in acceleration and deceleration around corners in a toolpath. If you've never changed the default settings, then 191 will be set to medium and 85 will be set to 25 thousandths. These are good baseline numbers, but they aren't optimal for every circumstance, which means you're not getting as much out of your Haas CNC as you can. The part file I'm using for this demonstration is a mold core for a computer case. There are three operations that we'll be looking at: a dynamic roughing operation, a 2D contour that finishes the open pocket, and lastly, an equal scallop 3D finishing toolpath. Let's start by looking at the details of the dynamic roughing operation. On the cut parameters page, we can see that we're leaving 10 thousandths on the walls. On the arc filter tolerance page, the total tolerance is set to 2 thousandths. What this means is that the tool can deviate from the 10 thousandths we're leaving on the wall plus or minus 2 thousandths. By giving Mastercam this small amount of flexibility, it can calculate the most efficient toolpath. There's no reason to have a tighter tolerance on a roughing operation. Even if the resulting toolpath ends up 8 thousandths away from the wall in spots, we're still going to have to finish the part with a separate operation. Tightening that tolerance to try and keep the tool at 10 thousandths from the wall is just going to increase the regeneration time and also the number of NC lines of code at the machine. If you'd like to learn more about arc filtering, tolerances, and how they affect your G-code, please check out the video on advanced toolpath display that is part of this series. Next, let's look at the other two toolpaths. For the 2D finish contour, the total tolerance is set to 1 thousandths. Moving over to the equal scallop toolpath, the tolerance is set tighter at 1/10. Having these tolerances set to appropriate values that best reflect the requirements of each operation is incredibly important. However, with most modern machine tools with high-speed machining algorithms, this is only half the story. It's imperative that we also communicate to the control how accurate we want these parts, and to cut them as quickly as possible. To do this on the Haas, we're using G187. This can be controlled via miscellaneous values in Mastercam when using any of the default Mastercam Haas post-processors. We'll go into the parameters for the dynamic roughing operation and navigate to the miscellaneous values page. Here we can see that in the third row of miscellaneous values, smoothness, or the P value, is set to 3, and the E value is set to 1 thousandths. This corresponds to fine in setting 191 and a corner rounding value of 1 thousandths. Because this is a roughing operation, a value of 3 is going to provide far more precision than we need, which will likely slow down the machine feed rates. To change this, we'll uncheck Automatically Set to Post Values when posting. Next, we can set that P value to 1. Mastercam's dynamic motion inherently eliminates sharp directional changes throughout the toolpath. Because of this, the corner rounding, or E value, is much less important. But I will increase the max corner rounding to 50 thousandths to allow the machine to maintain feed rate if the control deems a corner round necessary. If you're not using dynamic toolpaths and have sharp corners in the part where the machine must accelerate and decelerate quickly, this larger E value will certainly help make the machine produce a smoother transition and maintain feed rate. Moving to the 2D finish contour operation, we want more accuracy than our roughing operation. So we'll set the P value to 2 with a corner rounding value of 25 thousandths. Lastly, the equal scallop finishing toolpath will benefit from a tight tolerance, so I'll leave the defaults in place, which are a P value set to 3 or fine and a corner rounding of 1 thousandths. So far, we've been adjusting these parameters on a toolpath by toolpath basis, which might be fine if you only have a few toolpaths. But what if you have dozens or even hundreds of toolpaths? What you can do then is hold down the Control key and individually click on multiple operations, or hold down the Shift key and click on the first and last operation in a range to select them. Now, simply right-click in the Operations Manager and choose Edit Selected Operations. A flyout menu will present you with more options, and for this, we'll select Edit Common Parameters. In this dialog, we can activate the Miscellaneous Values tab and change these values to whatever we need. Mastercam will make the changes in all of the selected toolpaths for you. Miscellaneous values aren't the only things we can change for multiple operations in this dialog. We can change numerous items like spindle speed, feed rates, tools, and planes. Let's go back to the Operations Manager and select all 3 of the toolpaths. Once selected, I'll post them out, give the NC file a name, and now Code Expert will launch and display the posted code. Let's do a search for all the instances of G187. In the NC file, we get a G187 P1 E.05 for the dynamic roughing operation. At the end of the toolpath, there is a separate G187 to cancel it. There is a G187 at the beginning of the contour finish operation with the values we entered in the miscellaneous values page, and another G187 to cancel at the end as well. Lastly, the equal scallop has a G187 with the values we entered. We're tightening our P and corner rounding values as we move through the toolpaths, and since those values are being set in the G-code, the control will dynamically change the high-speed machining modes to match the intention of the programmer. If you're unfamiliar with adjusting the high-speed modes on your machine, what I really recommend is taking some time and experimenting. Trust me, this is time very well spent. Understanding what these values do and how you want to utilize them can help you realize the full potential of your investment in your Haas machine tool and the HSM option. A few simple changes can make huge improvements in cycle time and finish quality.